Now that we know how to name things, how to format our code, and how to write clean functions, which is super important, we're going to have a look at control structures in this course section, at loops, and most importantly, if statements. Because it turns out that control structures play an important role when it comes to writing clean code. To be precise, you want to avoid code like this. This kind of code is also sometimes called arrow code because it looks like an arrow from left to right, and we have deeply nested control structures here. If statements that contain for loops, which then contain more if statements, which then yet again contain nested if statements. This is super hard to read, super hard to maintain, error prone, and therefore definitely not clean at all. In this course section, we are going to work on this example and learn different techniques and rules which we can apply to turn this into cleaner code. Therefore, specifically in this module, we're going to have a look at how to avoid deeply nested control structures like the one you just saw. We're going to have a look at error handling, try-catch, and how to utilize errors in your application instead of using if statements. And of course, as always, and as you just saw already, we're going to do all of that at a concrete example. You're going to see demos, and I will also give you a chance to practice what you learned. Now, I have one warning about this section. This will be a very practical section. We'll have less slides and more refactoring on the code. This long code, which you see here, will change a lot throughout this section. We'll refactor it a lot, and we'll even refactor our refactoring results. Because that is how you write clean code, and I can really show everything we learned up to this point, including some new concepts you should be aware of at this concrete example, and I want to take you with me on that journey of improving this code. So if you're not a fan of refactoring, and if you're not a fan of seeing code change a lot, then A, clean code and writing clean code will be difficult for you anyways, and B, this section might not be so great for you. Nonetheless, what I will show you is super important and is how you do actually write clean code. And this section is less about tons of new rules and concepts and more about applying what we already learned combined with some new rules and concepts. So therefore, let's dive in. Now, before we dive into this messy code I showed you and before we will start cleaning it up, let me give you an overview over the various techniques and rules which we have when it comes to cleaning up control structures. Because of course, an important part of using control structures in a clean way is that you avoid deep nesting. To achieve this, we can use factory functions and polymorphism, and we'll of course see what exactly that is and how it helps us. You can also tweak your naming or the way you formulate your if checks a little bit, and for example, prefer positive checks over negative checks, because positive checks are typically a bit easier to understand. And you can also utilize errors and not just see them as a problem, but instead use them in a smart way to get rid of certain if checks which you don't need actually. Of course, the composition and polymorphism and the error part here will also be important tools when it comes to achieving the main goal of avoiding deep nesting. Now, these are all concepts we're going to have a look at throughout this course section, but I will actually start with a different concept: guards. When you have deeply nested code like this, it can be overwhelming if you look at this code. Where should you start? Well, you're going to see various ways of slimming this down and making it cleaner throughout this module, but one very efficient tweak, which you can make in a lot of cases, is that you use so-called guards and that you fail fast. Now, what does this mean? Take a look at this simple snippet. We have an if check here, where we check whether an email includes an @ sign, and if that's the case, we do a bunch of work inside of that if statement. And that bunch of work could be multiple lines of code. It could be as much as all the code you have here in the outermost if statement. So all this code here ultimately is in this one if check here. Now, if you have a case like this, you often can use a guard, which means you simply invert the if check. For example, in this case, by checking for the opposite with an exclamation mark, so for the email not including the @ sign. And this is JavaScript, but of course you can do this in any programming language. The exact syntax might just matter. And then you do one important other thing. You just return inside of that if statement. And that means that you now use this if check as a guard. It runs before your main code runs. And if you make it into this if check, so if some condition is not met, in this case if the email does not include a @ sign, then you fail fast. Which means you return, which in the context of a function means that the code thereafter, all the code after the if statement, won't execute. This is what makes this if statement a guard. It guards the rest of the code. If this condition is not met, because we fail fast, we avoid that the other code will run at all. And we had the same behavior on the left side, but there the to be executed code was inside of the if statement, and therefore it was nested inside of it, making it harder to read. A guard is typically way easier to read and to understand. And you cannot just use that if you have one if statement which wraps all your other code. You can also use a guard if you have a nested if statement in another if statement. For example, let's say here, has purchases. We could also outsource this and turn this into a guard where we fail fast, so that we then have two consecutive if statements instead of one deeply nested one. And this is a super efficient technique for removing unnecessary nesting. Now let's apply it to our example. Now how can we add a guard here? Definitely feel free to try this on your own, and for that of course you can pause this video and then try restructuring this code such that you are using a guard in there and that you fail fast. And you should be able to get rid of some nesting by doing that. So here's your chance to pause the video, thereafter we'll do that together. Of course, before you try solving this, also have a look at the entire code, so all the code in the code file which you find attached, so that you get a feeling for what this program does, which kind of data we're working with, it's a list of transactions, and so on. And if you're not fluent with JavaScript and you're not ready to transform this because you're not sure how to write this in JavaScript, you should still understand the general idea of the code and what it's doing in general. And you can then also, of course, solve this in theory and or by writing down some pseudocode. So definitely give this a try, no matter if you write real code or not. Were you successful? You can easily add a guard by converting this if check, this very first if statement here, to the opposite. What we're doing in this if check is in the end we're checking whether transactions is a thing, so if it's not null to be precise, and if it is not null, we check if we have at least one element in there. Because transactions seems to be an array. So therefore, what we can do here is we can invert this. And we can check if not transactions, so if this is null, or if transactions length is equal to 0, so if we have no elements, so if we have no transactions at all, if the entire object is null, or if it's an empty array, then we make it into this if check. So now we inverted this condition. Instead of having two conditions, which both have to be met, we now have an either or decision where one condition failing is enough to make it into this if block. And all we have to do in there is then return. And once we added this, we can get rid of this if statement here, which wraps the for loop. So we can also get rid of it down there. Now you see actually here we had an else block, so we did not just return. So actually we can also put the content which was in the else block in there as well and then return. We still need to return to avoid that the rest of the code doesn't run, But if there was extra work, which we wanted to do in the else case, we can of course do that before we return. So we log this to the console and then we return. And this is a guard which we added, which already removed one level of nesting in this big chunk of code down there. Now there actually also is a second guard we can extract, which works a bit differently and which is harder to spot. So if you didn't spot that, that's no problem at all. That is why we are also doing this together. But maybe you can see it now if you have a look at the rest of the code. Which other guard could we find in there? A good indicator for a guard or for a guard being used is if you have a if statement with a lot of code inside of it, where you then maybe have an else statement with some error message or anything like this. And we do have this here for this if check, where I check if a given transaction inside of this loop has a status of open. If that's the case, then we do process it depending on the method that was used. We have different functions, fictional functions which are being called. These functions do exist, but they just log something to the console. But if the status is not open, if we don't make it into this if check, we make it into this else block and we log this to the console. So this if check could also be replaced with a guard-like object. We could add a if check here and check if the transaction status is not open. So again, the idea of a guard is that we invert the check. And if it's not open, then in this case, I don't want to return because I'm still in a loop, which I want to continue going through, but I can use continue. And statements like continue and break exist in most programming languages. In the context of a loop, it means stop the current iteration and continue with the next one. And that's what I want to do if I make it into this guard. I don't want to try processing this as a credit card or PayPal or plan payment or refund. Instead, I just want to continue with the next loop iteration so that we have a look at the next transaction. Now we also printed an error message, so I will do that first before I continue. And now we can get rid of that else block here. And we now also removed one extra level of nesting here. Now we can have the same logic here for the refund case. So here we can also get rid of this and add our guard instead and get rid of this else statement down there. But of course, now that we have the same code in both these branches for the payment and the refund, we can also take this guard and remove it from these nested branches and instead lift it up to the beginning of this for loop. Now we check for this status right at the beginning of the iteration and continue with the next transaction in line if the status is not open, and continue processing the transaction otherwise. And that again makes that code already a bit more readable because we removed one level of nesting here. Now, of course, with this transaction status guard added here, we should also remove this wrapper if check here in the payment branch, just as I did it in the refund branch. And for the moment, that's it for guards here. Of course, this is not the final code and we'll clean it up way more than that, but this is a start. Now we at least use guards to make this code a bit more readable. So now we added guards. If we leave aside the fact that we have a bunch of if statements here, we should see another problem with this code though. And that is the mixture of levels of abstraction. What we learned about functions still applies. This is inside of a function after all. And when it comes to simplifying control structures and managing deeply nested control structures, splitting up functions and extracting control structures into functions is another important building block. Now this starts with the checks here. We can run the checks here in line, but we could also outsource this into a separate function, which then also would allow us to use positive wording. For example, here we are interested in whether we have transactions or not. So we could grab this code, cut it, and add a new function below this process transactions function. And we could name this function isEmpty. and then simply return the result of this check. Of course, ensure though that we get transactions as a value. So isEmpty will return true if we have no transactions object or if we have no elements in transactions. And I named this isEmpty and not has no elements because of this prefer positive checks rule here. It simply is easier to read if we use a positive statement than a negative one. So if I name this isEmpty, I can simply check here in process transactions if isEmpty transactions. Passing transactions to isEmpty. And this is super easy to read. If isEmpty transactions, then we do this. Now, of course, speaking of mixed levels of abstraction, we do have more violations of that rule. For example, also this console log statement. It's not directly related to the if statement and to simplifying the if statements, but of course we might also want to extract that. So we can grab this console log statement and add another function here. Show error message could be the function name, where we get the message as a parameter and where we then simply output the message like this. And then we could call show error message here and forward this message which we want to show to again have an equal level of abstraction here. Now, of course, extracting these two functions didn't remove the if statement. It also didn't shorten this code here, but it makes it a bit more readable. And overall, that is our end goal still. Nonetheless, when we talk about extracting functions, it's not just about extracting Boolean checks and deriving Booleans or showing messages. It's also about extracting entire control structures from our code. And that's therefore what we're going to do next. So now in process transactions, we have our guard, we have our for loop. I want to keep the for loop here because after all the function is named process transactions. So it makes a lot of sense that we go through all the transactions there and process them. But what we do inside of the for loop could very well be outsourced. Not this guard, I want to keep it here because I call continue, I execute the continue statement here, and therefore I want to keep it close to the for loop code itself. But what about this code down there, where we check whether it's a payment or a refund, and then we process the different methods, or if it's an invalid transaction type. This code could definitely be cut and outsourced into a separate function. That would already make process transactions way slimmer. So therefore we can add a new function here and maybe name it process transaction. So not transactions, that's the function name we have up here for all the transactions, but inside of the loop, process transaction for a single transaction. Hence here we get the transaction as a parameter. And I know that the word transaction is everywhere here. You can go for a different name if that's confusing to you, but I want to use a name that best describes what's in that variable or parameter, and it is a transaction after all, so I will stick to this name. And then inside of process transaction, I will paste in my code here. Since I use transaction as a parameter name, this code all still works because I'm still checking transaction here, transaction type, method, and so on. So this code still works, but now here in the for loop, after our guard, I can simply call process transaction for the given transaction. And that makes process transactions way easier to read and way cleaner. It's still not as clean as I would want it, but it is way cleaner for sure. We could now, by the way, even take our guard here and extract it from process transactions, even though I said I didn't want to do that, but we can do it because we're going to rewrite it, and move that into process transaction at the start and replace continue with return. We can do this here because process transaction will execute for every transaction. And we want to continue with the next loop iteration if the transaction status is not open. But since I have this as a guard in front of my checks down there, if we return here, this code down there won't execute. So since this is then therefore the only function which is being called inside of that loop, it's the same as continuing, but it's now even cleaner. Because now we removed more code from process transactions, and you could argue that this is now on the same level of abstraction. Maybe you would argue that this for loop is more lower level than calling some other functions, and we could therefore also extract this code into another function, but I personally have problems finding a good name for this function. We would have to name it something like loop through transactions, and that's essentially the same as describing what's happening in there, and it's also pretty much the same as process transactions. So finding a new distinctive name for this loop operation is pretty hard for me, and I personally would say that this code is very readable and clean. So I am fine with keeping this for loop here in process transactions for now, and then just outsourcing all the work to process transaction. The work for the individual transactions and the work for checking whether this transaction should be processed in the first place or not. So at this point, process transactions already is pretty readable and slim. Process transaction, on the other hand, is not. We got our guard here, but then thereafter we got all this code. And the question is, how can we simplify that? It will turn out that we can do multiple things, but a first step could still be that we extract even more functions. And therefore, of course, as always throughout this section, feel free to pause the video and try this on your own. Try to extract more functions which would make sense to you. After a short break, which you can use to pause the video, we're going to extract more logic together. So, did you find functions you could extract? I think one kind of function we could extract is a function that deals only with payments and a function that deals only with refunds. That's something we could do. So we could add a new function here, which we name process payments, for example, or process payment, because we're actually working on a single transaction, where we then get our payment transaction as an argument. And we could grab this code here, because we still need to check which method was used, and put that into process payment. And because I used payment transaction as a name here, I'm going to replace the transaction variable here with payment transaction. Now we get this code down there, and therefore here we can call process payment and forward the transaction. And obviously we can do the same here for our other transaction type, for the refunds. We can cut this and add a new function, process refund. Here we get our refund transaction as a parameter, and in the function body we have these if checks, and we work on the refund transaction. So let's make sure that naming is right. Now we got process refund, and hence we can call this here process refund forward the transaction. Now here we're logging an error, though with the addition that we also have a transaction here. So we don't just have a message, but we also print the transaction, which was the problem. And here we also have an error, though here it's just a message. Now we already have a show error message function, and we could now just tweak this a little bit so that it does not just print a message, but also information about the, let's say, item, which was responsible for the error. And we could therefore simply print the message and then check if item is set, so if it's not null, and then also console log the item, for example, so that we console log both the message and the item. And that's the JavaScript way of doing it. This check is important because item might not be set. For example, when we call show error message here, then we pass no second argument, and therefore item would be undefined, and I don't want to console log undefined. That's why I first of all check whether we have an item, and if we do, then we console log it. And with this tweaked show error message function, we can use it here to show an error message, And we can also use it down there to show an error message. And now with that, process transaction is way more readable. But we can certainly extract more. What about these checks? They are on a different level of abstraction than the rest of this function, because we just call our functions here, and then we have these low-level checks. Now, I personally think that's not this bad, because this is quite straightforward to read. Nonetheless, you could make the argument that you want to be extremely clean and that you therefore want to outsource this as well. Though keep in mind that you also can reach a point where you're splitting too much. And this here is definitely on the edge. Nonetheless, we could add a new function here where we check if the transaction is open and we get the transaction as a parameter. And then we return in the body the result of checking if transaction status is equal to open. And that should be transaction, of course. This was a mistake I made before as well. This should be transaction, not transactions, because it's inside of process transaction. Now here we can check if a transaction is open, or to be precise, if it's not open, by adding this exclamation mark. As a side note, you might argue that this is not phrasing this in a positive way then, but I would argue that the name of the function itself is phrased positively. It's is open, not is not open. And then we just add an exclamation mark, which is quite easy to pick up. Now we could definitely rename this to is not open and change the check in there to get rid of the exclamation mark here. And if you find that easier to read, you could of course also do that even though it's not phrased in a positive way. Now I will go back to not is open though. Alternatively, you could also name it is closed. The problem with that just is we don't know if the only other status is it being closed. So we can't check for this being closed. If there's also something like void or anything like that, then this check wouldn't succeed. So here I really just want to check for whether it's open and then not continue if it's not open. That's why I'm solving this issue like this. With that, however, we extracted this logic, and of course we can do the same here for the payment and the refund. We can add functions for is payment, where we get a transaction, and then return this check, and a function for checking if it's a refund. So here we have is refund, and we get a transaction, and we then simply return the result of this check up there. So return transaction type equals refund. And then we can just call is payment here and forward the transaction, and is refund and forward the transaction. And now we got rid of these mixed levels of abstraction, and we now got a pretty readable process transaction function. Nonetheless, we're not done yet. It's definitely way cleaner than it was initially, but what about these two functions, process payment and process refund? These functions actually have code duplication, kind of, inside of them, and they also are still not super clean, you could argue. So what can we do about them? The problem we have with process payment and process refund is that we have some kind of code duplication in there. We have the same kind of checks which we run in there. And that's bad, because that means that we repeat ourselves, which we of course shouldn't do, as we learned. The problem just is that for these different checks, we then do different things. We process credit card payments and credit card refunds, which are different functions, which, of course, that should be easy to imagine, do totally different things in reality. Here we just log something to the console, but that's just some dummy code. In reality, there's a big difference between charging a credit card and refunding a payment to the credit card. So it makes sense that we have different functions here, and we probably won't be able to merge these in an elegant way. Though there actually is something we could consider doing to slim this code down and to make it more readable. We could kind of inverse our checking logic. Now, what do I mean by that? Currently, we first check whether we have a payment or a refund, and then we process this payment or a refund, which means we then have these checks. Of course, we could theoretically also first check what the payment method is, since we have the same methods for both payments and refunds, and then only check if it's a payment or a refund in the second step. To check this, I will actually get rid of checking for is payment and is refund, though I will keep these functions, but instead I'll add a new function where I want to check whether a transaction uses a credit card, PayPal, or a payment plan. So we can name this function uses credit card, and we would get a transaction here. And then I want to essentially return this check here. So I return transaction method equals credit card. And we can repeat this function to also have a uses PayPal function where we check for PayPal as a method, and to have a uses plan function where we check for plan as a payment method. We could even merge these together and just have a uses transaction method function where we get the transaction and the method, and we then have this comparison here. It's up to you which approach you prefer. With such a method added though, we could go to process transaction and not check first whether it's a payment or a refund, but instead simply check if we use a certain transaction method for the given transaction. For example, if we use credit card. And if we do that, then we'll do something here. Else if we use another method, let's say PayPal, we do something else. And last but not least, if we have a transaction where the method is plan, we do yet something else. Now, what are these something else's which we want to do? Well, that is now our processing for credit card transactions, PayPal transactions, and plan transactions. So these would be new functions which we can add. We can add a new function here, maybe above process payment, which is named process credit card transaction. And here we get our transaction no matter if it's a payment or a refund. And we can do the same for PayPal to have a process PayPal transaction, and the same for a payment plan, so process plan transaction. And we'll add logic to these functions in a second. So now we have these three functions, and these are the functions which we want to call here. So we want to process a credit card transaction here and forward the transaction. In the next if branch, we want to process a PayPal transaction and forward the transaction. And in the last branch, we want to process a plan transaction and forward the transaction like this. Now we will eventually remove this code. I'll just leave it here for reference for a second. But now we have these functions which are being called depending on the transaction method. So the check which we previously had inside of process payment and process refund now moved up one level directly into process transaction. Therefore, to fully invert our logic, we now have to move the payment and refund logic down one level, out of process transaction into these process credit card, PayPal, and plan transaction functions. Hence, now in all these functions, we have to check whether we have a payment or a refund. And that is what I meant with we invert the logic. We will still have some duplication. There is no way around that because we had two dependent kind of if checks. But now we have the more complex if check where we replicated three different checks at a higher level, and we have the easier check where we only have two options at a lower level. But on the other hand, we execute this check 3 times now, so overall we can question whether we gain a lot. Nonetheless, let's finish this before we look for an even more elegant solution. So here, in process credit card transaction, we can now check if we have a payment using this isPayment function which we defined before for our given transaction, or if we have a refund. for this given transaction. Or else we know it's invalid, and then we can show an error message and simply, well, use this code from before. Show error message, invalid transaction type, and pass the transaction as well, like this. And now if it's a payment, we know it's a credit card payment, so here we can call process credit card payment. And that's one of the functions which existed right from the start, one of these dummy functions. If it's a refund, we know it's a credit card refund, so we can call process credit card refund. And now we can copy that code into the other method functions here. So here we call process PayPal payment and process PayPal refund. And here we have process plan payment and process plan refund. And we can now get rid of process payment and process refund down there because we don't need these functions anymore. So what we did now is we inverted these checks. Now we check for the method at a higher level and then for the type of transaction at a lower level. Hence we can now remove this if check here from the process transaction function because that's the check which we now have in all these method specific functions. Nonetheless, of course, we have duplication here. And just like this, we also won't be able to get rid of it because we're in the end just Before we're going to explore how composition and polymorphism might be able to help us with that problem of duplicated checks, which I outlined over the last lectures, let's see how utilizing errors can help us with our code overall. Because one mistake which quite a lot of developers make is that they don't utilize errors and throwing custom errors enough. And errors as well as error handling is really your friend. Because throwing and handling errors in the proper places can actually replace useless if statements and lead to more focused functions. And here's a simple rule. If something is an error, if something has an error character, make it an error. Don't try to solve it with an if statement. For example, here is a short snippet, which we don't have in our big example, but which you could see in other programs as well. Here we're checking whether something is an email, and if we make it into this if block, I do return an object here where I assign some code, probably some kind of error code, and a message. And then in other parts of our application, we could check for this object, check the code in there, and then run code depending on whether we have code 422 or if we maybe were successful. So in the end, what we're doing here is we're constructing an error without really using the built-in error mechanisms all modern programming languages offer to us. This here would be a better way of writing this. We're having the same check, but now I'm constructing a real error building up on the built-in error object, which also all modern programming languages give you in some way. I then add extra data to this error object, in this case a code field, which I set to 422, and then I throw this error. Now this again is JavaScript, but similar mechanisms for building and raising your own errors exist in all programming languages pretty much. You can always build errors either using built-in error objects or building your own ones to add any data you might need to add, and then you can throw these errors, and then, and that's the key part, you can also handle these errors. And if we come back to our example, we have a couple of places where we are doing error-like stuff without really using errors. For example, here in process transactions. Here we are checking if we have no transactions, and if that's the case, we're printing the error message. Now we could argue that from a clean code perspective, printing the error message should actually not be part of processing the transactions. Processing the transactions should really just do that. Go through the transactions and do something with them. Checking whether they are valid would be okay, but handling the "they are not valid" case, that is actually too much. It would be better to do that in the place where we call process transactions, which is this main method I provided to you right from the start, where we also have some dummy data. And that's exactly where we can use proper errors instead of doing it like this. Now, one naive solution would be that we actually return an object here where we do what I showed you on the slide. And we have a code of 1, let's say, which stands for we have an error. And I then have a message of no transactions provided. And we return this in the error case. And then here in the main function, where we call process transactions, we get the result back from process transactions. So this object, we store it here. And then we check if result code is equal to 1. And if that's the case, we know we have an error. And then we show an error message. And the message which we do show also comes from the result. And it's that message field. This is what we could do. This is how we could handle this with an error-like approach. And it is better than having the message here, or the logic to show this message here in process transactions, but it's bad because we now wrote code which requires an extra if statement and which doesn't really utilize the built-in error support. Hence, a better way of doing that would be to create a proper error. In JavaScript, we can do this by instantiating the error object. This error constructor also takes the message as a parameter. Then here in JavaScript, we can easily add extra data by setting a property like this, even if it didn't exist before, and setting this to 1. And then we can throw this error. Now, to have an even cleaner way, we could also create our own error class, which extends the built-in error class. But this is the quick way of doing it, and I just want to focus on the general concept here. So now we can remove this return statement. Because of the throw keyword in JavaScript, this code execution will stop anyways as soon as we throw. So this code down there will not be executed if we throw an error. And therefore, this error will then bubble up throughout our application, and we now need to handle it. That's the other part of working with errors. And as in so many applications, we can handle our error by using try, catch, or in Python, for example, it's try except. There we catch our error and we try processing the transactions, where we now no longer get back a result. And instead here, when we catch the error, we show our error message with this show error message function. And this is now a proper way of dealing with this. Now we're using the built-in error mechanism to ensure that the error message is triggered in the right function and that the error is generated as a real error instead of some dummy object. This is the proper and clean way of doing it. Use errors where you have errors. Now, of course, in our demo application here, we got two other places where we in the end are dealing with errors. And that's here in process transaction, this check, where we see whether a transaction is open or not. And then in all these processors here, in all these process transaction functions down there, we also print an error message if we have neither a payment nor a refund transaction. So if we have some invalid transaction type. Again, a better way of handling this would be to generate a real error and then treat it somewhere else. So let's maybe start here in process transaction. If the transaction is not open, then we can create an error, a new error, with a value of invalid transaction type. This is my message. And then I want to throw this error. Here I don't add a code because here for this logic I don't really need it. That was just from the example before, showing you that you could add this code, even though we also don't use it here, by the way. We add it, but we never use it. So you could remove it here as well. We definitely don't need it down there, but now we're throwing an error instead of handling the error here. Now we can do the same here for process credit card transaction and process PayPal transaction and so on. Here we can also create an error, a new error with this text. And here we can add some extra data, for example, the item which was responsible for this error, which is the transaction that caused this. And then we throw this error. Now we just have to repeat this code in all these functions. And as you know, repeating code like this is bad. So what could we do? Well, we could again utilize a guard. We could remove the code from here and remove this else statement in all these process functions. And instead move that here to process transaction. Before we actually start triggering process credit card, process PayPal, and process plan transaction, we could check whether we do have an invalid transaction. Simply by adding an extra guard here. Here we could check if we have neither a payment nor a refund, because that is the check we had in these nested functions before. And if that's the case, we want to generate and throw an error. So we added a new guard to move some nested logic out of these nested if statements to a higher level, because we can already perform this check here and check for whether we have a payment or a refund. And if neither of the two is the case, I want to generate an error. Now we generate and throw two different errors here in process transaction. The question is, where do we now handle them? And the answer is not here in this error handler which we added before. Because we must keep in mind that these errors are thrown for single transactions. So they should not stop processing all transactions. They should just stop processing this specific transaction. Hence we want to handle the errors here in this for loop. Here we can add a try catch block and try processing a transaction, but catch an error if we got it. And then show an error message here, forward the error message, and the error data, or the error item was the name I picked. This may be undefined for some errors, but that's no problem because we have a check for this inside of show error message. So now we moved this around and we're using proper errors for, well, working with errors, because that is what we have here. And doing that instead of using if statements where we then log something in place is definitely recommended. So by now we already refactored a lot. I'm fully aware of that. But this is how you do write clean code. It's a step-by-step process, which is why I'm showing it in great detail here. Because that is what you will do ultimately when you clean up your own code. It's about trying out things, being creative, and moving things around. And speaking of moving things around, we now use errors, which is great. But now we have all that code for creating errors side by side with code that, for example, dispatches different process functions for different transaction methods. This again is mixing different levels of abstraction. So we should consider splitting our functions. For example, here in process transactions, where I check for whether my transactions are empty to then create an error. We can create a new function which we could name validate transactions, where we get all the transactions. And then we move this code, where we generate this error, into this function. Then here in process transactions, we can simply call validate transactions before we go through this for loop. The great advantage of this approach is not just that process transactions is now slimmer, though we should forward transactions to the validate transactions function, but also that because we use real errors and we throw this error, we use a built-in mechanism in the programming language which will ensure that this automatically bubbles up. So it will just bubble through process transactions, canceling this function as well if an error is generated inside of validate transactions, moving up to the next function until it is being handled, which in this case it is here. And this of course is great. This here of course should be transactions, by the way, not transaction. Now we could argue that we have mixed levels of abstraction here. Calling is empty and then this low level code of creating the error and adding a code. And therefore we could also add another function here where we build this error. You could absolutely do that, but I will not do it here. I think it's too much splitting, and if you would want such a helper function which builds an error, I would recommend that you simply create your own error class which you instantiate here. So I will leave it like this. Nonetheless, we have some extractions left to do here for process transaction. There we check whether it's not open or if it's neither a payment nor a refund. And we can outsource these validations as well. So we can add a new function here, which we name validate transaction, for example, receiving the transaction as a parameter. And now we could either create one function for each check here, or we take both checks and put them into the same function. Which I will do here because we're doing the same kind of work. We're validating a transaction, just with different checks, and therefore having this in one function makes a lot of sense to me. And now we can just call validate transaction here before we then try to process the different transactions. And again, because validate transaction throws an error, if we got an error, this process transaction function execution will be cancelled if an error occurs, and this code will not be executed. Instead, we move up to the next function above it until this is being handled, which in this case is happening here in this for loop. And that now again were more extractions which hopefully overall help with readability if you would read this entire code top to bottom. So now we got all this nice error throwing and error handling code. I got one last rule or recommendation related to error handling. And that is that error handling actually is typically considered to be one thing when we talk about functions doing one thing. And what's the implication of that for our code? In the main function at the top, we have all this dummy data, but then here we have our try-catch block. And since this is just dummy data here, we can basically ignore it. This could also be in the try block where we then maybe try to fetch it from a website or anything like that. So here we in the end have just one thing. We just have the try-catch block inside of this function. Of course, we do something in the try and in the catch case, but that's the entire idea behind try-catch. It's not about not doing anything in here, it's just about not doing anything in addition to this try-catch block, which is the case here. But for process transactions, it's different. Here we validate, then we have a for loop, and then in there we have try-catch. So here we are doing more than just error handling. We are also looping and validating. Now, one way around this could be that we move try-catch actually into process transaction. So kind of back to where it came from, you could say. So let me grab this catch block, remove the try block, so that we just have process transaction in the loop again. And now inside of process transaction, we could add a try block here and move validate transactions as well as all this if code here into this try block, and then add the catch block from before with show error message. This could be one way of fulfilling this rule again and of ensuring that we do only one thing. We try validating and then doing this, and if that fails, we catch the error. Now, having this code in here is still not super clean. It would probably be cleaner to validate and then just call another function which contains this code. But the question is, how would we name this function? Is this a split which really makes a lot of sense? We could try it and, for example, add one other function here above uses transaction method maybe, which we name process by method, and we pass our transaction in there, and in here we then check for the method and then dispatch our different process functions. And now we could call process by method here and forward the transaction inside of the try block. And now this is cleaner, and this down there is also clean. And that's how I would recommend that we solve this here, though as always, it always also comes down to personal preference and what you find to be clean and readable. With that, however, we're now really done with all the error handling. Now I want to come back to this problem of our code duplication down there and how we can maybe solve that in a better way. Now let's come back to this problem of having some duplicated code and having all these extra checks for whether something is a payment or a refund. We can solve this problem by utilizing factory functions and polymorphism. And for that, of course, we need to understand what a factory function is and what polymorphism is. A factory function is simply a function which is used to produce something. For example, to produce objects or produce maps, arrays, anything like that. We provide a certain input and it then produces a certain object for us. Polymorphism is a concept to which I will come back to in the next course section, which is about classes and objects. In the end, it means that we can have an object or a function which we can always use in the same way. For example, an object on which we always can use the same method. But what this method does in detail then depends on some other factors. And we can combine this to write a factory function which produces different other functions or objects with functions that we can always call in the same way, but that then sometimes handle credit card payments and sometimes handle PayPal refunds, for example. And that is exactly what we're going to work on now. We're going to write a factory function which creates an object which always will have the same structure, but then different code that executes under different circumstances. Let's go up to the process transaction function again. Here I call process by method to then trigger this function. Now I will replace this function. So we'll add a new one and soon delete the old one. And I will name this function getTransactionProcessor. And this function will be a factory function. This function will return an object, and it will actually return a polymorphic object full of functions which always have the same name, but will do different things. That's the plan here. And for that, we will utilize the fact that in most programming languages, you can indeed use functions like regular values. So you can assign functions to variables, to properties. You can pass functions around. And we're going to do that because we are going to return an object full of functions which already exist, but which we won't call in here, but which we will just swap dynamically depending on which function we need. But it will become clearer as we start working on this factory function. And for this, I want to utilize the fact that functions in JavaScript, but also in many other programming languages, are callable, but don't have to be called. And if you don't add the brackets after the function name, you can use them just like any other value, like a string, a number, or an object. So now with that, we can grab this code here and move that into getTransactionProcessor, and then add a new variable here in this getTransactionProcessor function, which in JavaScript we do with the let keyword, which I'll name processors, because we have two possible processors for every transaction, a payment and a refund processor, at least after going through these checks. Now in here, in this object, which I create like this in JavaScript, or a map in other programming languages, I will add two keys. Payment with a value of null initially, so no value, and refund with a value of null initially. Now the idea is that we populate payment and refund with functions as values inside of these checks. So here, if we use a credit card as a payment method, I will set processors.payment equal to process credit card payment. But I'm not calling this function. I'm not adding parentheses. I'm just pointing at it. So this process credit card function, which is defined down there, I'm pointing at it. I'm using it as a value. I'm not executing it. And I'm storing this pointer at this function in this key, in this object or map. So here, I'll then do the same for refund and store process credit card refund in the refund field of this map. Again, just pointing at it. And we can now do this here in all these cases and just point at the different processor functions. So here it's process PayPal payment at which I'm pointing. Here it's process PayPal refund. And here it's process plan payment and process plan refund. So now we're populating this object and I am simply returning this object thereafter. So in this getTransactionProcessor function, I'm creating this object, populating the different processors depending on the payment method which was chosen, and then I return this. Now with that, we can get rid of the processByMethod function. We should keep the isPayment and isRefundHelper functions, but we can get rid of the process credit card transaction, process PayPal transaction, and process plan transaction functions. So we remove a lot of code here. In getTransactionProcessor, we should now accept the transaction as a parameter, because we're using it here to derive the method. And now we're creating this object here, which we can now utilize by calling getTransactionProcessor here in the process transaction function. Instead of calling processByMethod, we now get our processors by calling getTransactionProcessor and passing the transaction to it. And now we can simply check if we have a payment for the given transaction, in which case we want to call processors.payment and execute this as a function and pass the transaction to it. Else, we can call processors.refund and pass the transaction as a function. And of course, now we can also outsource this out of process transaction to keep it clean, and maybe add a new function here, which we call process with processor, accept the transaction as an argument, and copy our code in there. And now it's process with processor, which we can call here. Though again, you can argue whether this really is a good split or not. It definitely makes this function more readable, but now of course we have to scroll down to process with processor. Still, I would argue both functions are easy to find and readable, and therefore clean. We could also rename these keys here to make it clear that they hold functions, and rename this to make payment and make refund, for example, or process payment and process refund. And of course, then also use process payment here when we store a function, and process refund when we store a function. And with these properties renamed, we can call process refund here and process payment here. But that's just some renaming to make it clearer what's inside of these properties, which we of course should do to write clean code. And now with that, we got rid of these extra nested if checks, because now we're using such a map of functions which we return. So in the end, getTransactionProcessor is a function which just returns a map of other functions. Maybe therefore we should rename it to getTransactionProcessors and also call getTransactionProcessors here, of course. Because now this will give us an object or a map full of functions which we then can call to process the transaction appropriately. And this is a technique we can use to make this code slimmer and to remove all these duplicate checks. Now we're almost done with this long, practical section here. There are still minor improvements we could make and you should consider. And that would, for example, be that in show error message, we sometimes call it with just a message, and sometimes, of course, we call it with a message and an item, which is why we accept both, message and item. Now this is okay, we have this if check here, but we can actually get rid of this pointless if check here if we simply always console log the item, but make sure that the item is never undefined. But instead maybe give it a default value of an empty object or map. And default parameter values, of course, are also accepted and supported in many programming languages. So now we ensure that there always is an item, even if it's just an empty map, which we then therefore output here. So that's a tiny improvement we can make here to get rid of one extra if check. Because as you saw throughout this section, getting rid of if checks can really help with readability. So that's it for this section. It was a long section with a lot of code, which we changed. Now we have this final result, though I will already say one piece is missing. And that would be polymorphism, which also can help us with solving that problem of having duplicate if checks. We solved it for now by having this map full of functions, which works, but there is another approach using classes and polymorphism, which I will also come back to in the next section, however, because the next section will be about classes, objects, and everything we need to know about them when it comes to writing clean code. So therefore, for the moment, this is the final state. And of course you might argue that this is quite a long file with quite a lot of scrolling required to move around. Now, of course, keep a couple of things in mind. For one, we got a bunch of dummy data here, which already occupies 30-ish lines of code. And then we got all these dummy methods down there at the bottom, which we of course also would have in reality with real code in there, but they would probably not all be in the same file. And in general, this long file could be split up. I have an example folder structure here in the final demo folder, which you also find attached. There I have a very lean app.js file where we just have the main function, process transaction, and process transaction. And then all the other functions which are being called in here are in the end imported from other files, which you find in subfolders. For example, the util folder has the error handling function and my validator functions. The data folder simply holds these transactions. And the processing folder has these functions that deal with the direct processing of the transactions. So the validation, and then also for processing with a processor and picking a processor. And of course, in reality, you would split up code like this or in a similar way, because that then makes the individual files easier to read and therefore also helps with achieving clean code throughout your entire project. You don't just want to have one endless file. Of course, for the purpose of this section and for showing everything without switching files all the time, I did do it all in one file. And even if you go through this file, therefore, it should still be rather clean. It reads top to bottom. We have these functions with good names, which we can call. And we used all these functions and all these various concepts covered throughout this course to ensure that we still have a couple of if statements and a loop, but we have less of them and we do combine them in a more structured way to ensure that we have way more readable code, even though it takes up more lines of code, than we had at the beginning. Because this was definitely harder to read and understand and maintain, and it had a lot of duplication inside of it. So now throughout this section, we learned how splitting this up into functions, something we already learned in the last section, and how a couple of tweaks related to if statements and how to name our conditions and so on can help us with turning this into a way more readable and therefore cleaner code base.